Hi, it's Dr. Paul here, and today we're going to talk about glucose-dependent insulin release. So the insulin that is released as a result of increased blood glucose. So originally what happens is we're going to see that glucose is going to make its way to the beta cell, and it's going to move through the GLUT2 transporter and into the beta cell. Now the beta cell is in the islet of Langerhans, okay? And these are sensitive to changes in blood glucose levels. Now, as glucose enters into the beta cell through the GLUT2 transporter, glucose is then going to enter into glycolysis, okay? And then it's going to move through different pathways like the Krebs cycle and oxidative phosphorylation, and it's going to create a bunch of ATP, okay? And those are created by oxidative phosphorylation. Now, as the levels of ATP rise, we get a significant boost in ATP to ADP ratios. And what happens when we have this increase in ATP, okay, is that the ATP-controlled potassium channels here, which are normally open, get shut. And as a result of that, this causes depolarization of the cell. Now, once depolarization occurs, the voltage-gated calcium channels are stimulated. Okay, and this causes an influx of calcium into the beta cell. Now, as calcium levels within the cell increase, and phospholipase C is going to cleave a membrane phospholipid phosphatidylinositol 4,5-bisphosphate into diacylglycerol and IP3. Now, the IP3 is going to bind to a receptor protein on the SR, and this is going to allow for the release of even more calcium from the SR via this IP3 gated channel. Okay, this further increases the concentration of calcium within the cell. Now, the increased calcium leads to an activation or expression of insulin via the CREB gene. This is the calcium responsive element binding protein. And what this is going to do, it's going to stimulate the release of insulin. Now, insulin is released in these vesicles. And so it stimulates the release, and as these vesicles make their way to the membrane, they're going to be exocytosed into the plasma, and then that insulin is then going to go, and it's going to help to take glucose out of the blood and have it uptaken into places like the muscles. And now you know how increased blood glucose levels will stimulate the release of insulin.